Thank you for coming. This is the last one of the day. We made it, right? Long day. Good news, though, I'm not talking about anything new. These are all things that we've all seen, but they're hard to keep track of, keep it all straight. So, little context. The web has grown immensely, exponentially over the last 20 years, right? I think we'd all agree. And applications have grown proportionally, right? Our JavaScript applications are getting larger and larger and larger. So, as an application grows, it's pretty obvious that it needs to be split up into modules. It needs to be, the pieces of functionality that relate to each other need to be broken off into different pieces, right? Models, views, controllers, if you use MVC, or reducers, or whatever else comes with React and Redux, all that stuff, they need to be in separate pieces, right? Well, that's the context, but the problem is JavaScript and the web platform that we build for doesn't really have a built-in way of loading modularized applications. It doesn't have good module support. So what are the solutions that we've come up with to that problem? That's what my talk is about, okay? So let's start kind of at the beginning. Script tags in the browser, okay? This is sort of the way we used to do it. We'd have just a bunch of script tags. We broke our application into pieces, and we load each piece individually, manually. We might start with our third-party dependency, and then we load up our modules, and then finally we load up kind of the main module that kicks everything off and gets everything started, right? Advantages of this approach is that you've got minimal setup. You just need a text editor and a browser, and you're good to go. It's simple. Disadvantages, obviously, there's a lot of them, right? Managing this enormous list of dependencies manually gets pretty unwieldy for any application of material of size, right? You're also making the user download hundreds of files, which currently is an anti-pattern. Also, in order for your modules to talk to each other, they have to communicate through the global namespace. That's just how it has to work. Not great, okay? Let's see what we've got, what other options we've got. Well, kind of in the same vein, how many of you are familiar with the Clojure compiler from Google? The Clojure library, okay, a handful. Well, sort of as part of that, they have a script called calcdeps, a Python script. And assuming that you use the Clojure sort of way of defining your modules, which is with this syntax, you've got goog, meaning Google, dot provide, and then a namespace. And then you implement your module with that namespace, right, in person.js on the top. And then in another file, in another module, you have people.js, and you provide your namespace, and then you require the other one, you require the person, and then you can use it. Okay, so this is kind of the Clojure way of doing things. So assuming you've done that, you can use calcdeps to, among other things, generate a list of ordered script tags for you. Okay, so in this case, you run it through and you get two script tags. You get person.js first, and then people, because person needs to come first. Okay, but at this point, you've introduced a build step, and if you're going to do that, there's a lot of other options, which I know many of you are aware of. But I just wanted to mention it. Okay, so along came the server then, server-side JavaScript. And servers typically aren't parsing HTML files looking for script tags to know how to load the application. So we had to come up with something different. Okay, so enter CommonJS. This is the CommonJS syntax. So you have one module that says module.exports, and then the function, or the functionality that you're exporting. And then in your other module, you have const helper equals require, and then some identifier to pull in that module and take that functionality and bind it to the helper. Okay, so this is CommonJS. Okay, anybody that does Node is going to be familiar with this because Node is probably the most popular implementation that uses CommonJS. Okay, so developed primarily for execution on the server. Advantages, speaking from the perspective of Node, I'm not familiar with any other server-side JavaScript, so I'm just using Node as an example. But the advantage is that it integrates really well with NPM, which is Node's package manager. And so this require method is implemented in such a way that If it doesn't resolve to a file, then it'll look in your Node modules folder, which NPM happens to use to put all your dependencies, right? So that's convenient, that's nice. Disadvantage, though, is that it's a global API, right? This require method is provided by the engine, and it's not, therefore, a standard language construct. So therefore, it doesn't automatically scale to other platforms, namely the browser, right? If we try to run this code in the browser, there's a lot of issues. Not the least of which is that require, as it is implemented here, needs to be synchronous. It needs to load that code synchronously and put it in the helper variable. If you were to do that in the browser, say you're making a request to get the file and get the code, that makes for a terrible user experience because they're waiting on these dependencies to load synchronously and it blocks their browser in the meantime, right? So not super transferable to other platforms, and it's a global API. Okay. So obviously we mentioned Node, right? If you want to learn more about the way CommonJS is implemented in Node, look at the confusingly but appropriately named modules module of the Node documentation, right? There is a solution, though, for the browser called Browserify. And the way it works, so it lets you require modules, so you can use CommonJS modules in the browser. And the way it does it is it bundles up all of your dependencies so that they're already loaded. So that's how you can synchronously get that code because it's already down from the server. Okay, so if you've heard of Browserify, that's what Browserify is. Okay, so that's the server, but still, what about the browser? What are we going to do besides managing script tags ourselves or using calcdeps.py or something similar? Well, enter AMD. Okay, asynchronous module definition. So that you can tell by the title that they're already sort of attacking that synchronous code loading problem, right? Asynchronous module definition. Here's the syntax. For your lowest level modules, use a global function called define, and you pass in your module. Okay. For the modules that have dependencies, which will be 99% of them, you use a global function called require. It takes 2 arguments. The first is an array of string identifiers that represent the modules that you depend on to implement this module that you're about to provide. The second argument is the module itself, and it is passed the dependencies that you asked for. You can see how I kind of matched up those names, right? So you can tell what's going on. So, like I said, developed primarily for the browser. It solves the global scope problem by wrapping everything in a function. The issue, among many, with AMD is that you have this crazy syntax. All of your modules have to be wrapped in these function calls, and that's pretty confusing, like for a beginner especially, right? If you're coming into JavaScript and you're looking at this, it's not super straightforward. I put here as an advantage and a disadvantage. It uses JavaScript to load JavaScript, so there's nothing special in the engine like we saw with CommonJS's implementation of require. It's just JavaScript, and so it's what you call a script loader. That's nice because it's immediately portable to other platforms, right? Because it's just JavaScript. It's also, I put disadvantage because, in my opinion, I think that kind of stuff sort of does belong at the engine level, right? I work at Lucidchart, and we use Scala for all of our back-end services, and I can't imagine any Scala developer being okay with using Scala to load other Scala. Right? It's just weird. It's a little bit strange. Okay. The nice thing, though, about AMD is that, unlike with the managed script tags, this will only ever load the code that you're using. So if you have a module that never gets required by another module, it never loads. So that's nice for your users, not having to download extra code. Really the only implementation of AMD that's probably worth mentioning is RequireJS. I'm sure there are others, but this is the only one that I'm familiar with. So the way RequireJS works is it implements, like we saw, define and require to asynchronously request files from the server. And those IDs that we were passing in the array, those are by default paths to a file, but you can also configure require to not necessarily have to be a path. You can pass in some other identifier that as long as it is configured to resolve to a URL, you're good. Okay, so that's RequireJS. Remember, RequireJS is AMD. Okay, so we've got AMD, we've got CommonJS. Well, wouldn't it be nice if we could use our code in both contexts? The server, which uses CommonJS, right? And AMD for the browser. Well, along came UMD, Universal Module Definition, okay? Developed to unify the browser and the server. And obviously, it supports both AMD and CommonJS modules. And the way it works, essentially, is it's not really anything new syntax-wise, anything different than these two. All it's really doing is taking your module, pass it to a method, to a immediately invoked function expression, and that thing kind of tries to determine what context you're in. It looks maybe on the window for a require implementation or a define implementation to see if it's AMD, or it'll check some other things to see maybe it's in a CommonJS or in a Node context, and then it will bundle up your module for you with the appropriate one. Okay, so that's UMD. Well, what tools support UMD, you might ask? Webpack. So for those of you who went to Brett Little's talk this morning, the nice thing about doing your talk at the end of the day is you can learn stuff during the day and then you can change your slides last minute. So I just learned today that the difference between Webpack and SystemJS. Well, I knew that they were different, but I learned some of those differences from him. So Webpack is a module bundler, meaning that during your build process, it will bundle up all of your modules, and when it does that, it can read AMD modules or CommonJS modules, and that's why I put it under UMD. Okay, it's customizable too. Another option is SystemJS. It's a module loader, so it doesn't necessarily bundle your dependencies at build time, although I'm sure you could make it do that. I've never used it, but the nice thing about SystemJS is it supports, obviously, AMD and CommonJS, and it also supports the new standard, ES6 modules, which we'll look at in a moment. It even supports global scripts like jQuery or other libraries that you might be used to. It supports the browser and Node, and as Brett Little pointed out this morning, it is a potential implementation for the internals of the ES6 module standard. Okay, so that's SystemJS. Okay, so kind of a wild ride. We've got all these sort of different standards and they're interacting with each other and we're trying to make them interop. Finally, it's 2016 and we have ES6 modules and they're not implemented anywhere yet. Okay, so here's a quick rundown of the syntax for ES6 modules. You've got, on the top, we've got named.js, meaning here is how you do a named export. Export const foo, so that's the name, and I set that to 100. Export function bar, again, that's the name, and it's just a simple function. Okay, so if you jump down to app.js, we are importing those from named by their names. Okay, so you can import exports by their name. But there's also a nice sort of sugar called the default export. So if you look in the middle, export default class, and so it's exporting a class. And then in app, where I'm importing these things, I happen to name them the same just to keep it clear, but they don't have to match. And really the difference is you don't have to have curly braces and you don't have to worry about what the thing was named when you exported it. It's just the default export, so you import it with whatever name you'd like to bind it to. And you can have named exports and a single default export for your modules. There's no reason why you can't have both. And so this is just some of the syntax. There are actually quite a few other nice convenience syntaxes, but these are kind of the main ones. And like I mentioned, the default allows for a more compact syntax. one kind of nuanced difference here that I'd like to point out. When you're importing from, you have to pass a path to the module, okay? I'm assuming that all of these pretend files live in the same directory, so I just use their names. But for large projects, you're probably going to want some tooling to help you find the path to the module that you're trying to import. You know, unless you like doing .. / and like counting the folders in your file tree, right, and trying to figure out how to load things. In my opinion, that's a little bit of a disadvantage to like we looked at the closure code, and that's just a namespace. So those goog.provide namespace is completely separate from the idea of a path on the file system. So it's more like Java, or right? You know, you have your import Java util base64 or whatever thing you need. That doesn't necessarily mean that source code lives in a folder called Java/util, right? So, but you know, I guess the advantage is that it helps you structure your applications in such a way that this will make sense. Okay, so we want to use ES6 modules. What are our options? Well, we've got Babel. It compiles your ES6 import-export syntax, and incidentally, all of your ES6 features into valid ES5. Well, how does it do that? Here's an example ES6 on top, export const foo, just like we saw. And this is the default output for passing it through Babel. You'll notice right here, exports.foo should look familiar, and it should tell you, oh, that's CommonJS, okay? So by default, Babel takes your ES6 modules and compiles them to CommonJS. So it works out of the box with Node, which is nice. It can also be configured to compile to AMD. So you still need, obviously, then a CommonJS environment if you're gonna run these. So like I said, it works out of the box with Node. If you want to use it in the browser, you're going to need something else. Webpack, SystemJS, something else, okay? What else do we have? Well, we've got Typescript. We use Typescript at Lucid. To be honest, when I first heard about Typescript, what I thought of was, oh, it's something like CoffeeScript, right? And I don't want to learn that. But as I've actually started using Typescript, I've realized it's just ES6 with a thin layer on top that provides type annotations and type inference and stuff. And so I've actually become a big fan of Typescript. So you can write your ES6 and with Typescript and use the Typescript compiler. And so there's the input, and here's what the Typescript compiler outputs. Should look familiar by now, right? It outputs to AMD by default, although it can be configured to output to CommonJS or UMD. You can even use a tool called tsickle to compile your TypeScript to ES5 that is annotated with JSDoc type annotations, which is what the closure compiler will take in. Okay, so that's TypeScript. Still requires an AMD implementation, like I mentioned, so you're going to have to use Require or SystemJS or something. Okay, so moving forward, what do we do? In the browser, possible recommendation, you transpile your ES6 modules with Babel or TypeScript and load them and bundle them with SystemJS or Rollup.js, which is another one. On the server, the nice thing about Node is that it already supports a lot of ES6 features. Import, export is still in the works as far as I can tell. You'll notice that I have MJS crossed out here. A little background on how Node is thinking about implementing ES6 modules. Basically, they had to figure out, okay, if we're going to support ES6 modules, we need a way to know, is this thing that I'm loading an ES6 module or is it a CommonJS module? And kind of the initial proposal for the standard was, if it's an ES6 module, we're going to make us, developers, name our files with a .mjs extension, to M meaning module, right? And as flattering as it would be to have a file extension named after me, those are my initials, MJS, it turns out that that's not the best idea. So let me see, check my notes for who was it. Dave Herman, Yehuda Katz, and Carity Patino wrote kind of a counter proposal called In Defense of .js. And basically what they were saying is, don't make developers have this other file extension for ES6 modules. Instead, let's use JS like we always have, but we'll put a little bit of metadata in the package JSON to help Node know what to do with that module. Okay, so that's coming in the pipeline. That's I saw that proposal got amended fairly recently with that change. So yeah, so on the server, use Babel or Typescript if you need more ES6 than what Node already provides. A little side note before we finish up, because it's kind of related, with HTTP 2, right now it's kind of a best practice. I'm sure many of us in here are doing it. We have all of these modules, and we used one of these tools that we've talked about to bundle them all up and then send it all down in one big blob to the user to download. Right, because HTTP requests are relatively expensive, network requests. With HTTP 2, that changes a little bit. When a server receives a request for, say, index.html, it can respond with index.html and then also say, here's a bunch of stuff I know you're going to ask me for anyway. So here's some scripts, here's some CSS, right? And it can kind of send those all down at once, which makes it appear faster to the client, right? And because it can send all these assets down in parallel, it might actually become a best practice to not bundle the JavaScript and instead send them all down individually, because then they're smaller files and they're coming down in parallel and they come down faster. So just be on the lookout for that in the future. That's it for me. If you'd like, the slides are available online, as you can see. It's my website, mjswensen.com, and if you'd like to connect on Twitter, my handle is mjswensen, just the same as the domain name. So thank you so much for coming.